Hi, so today I'm going to be explaining all these different structures, or going to be basically explaining discs, washers, discs/washers versus the shells method, of course. I've got here the horizontal x-axis, which means x-axis lines y equals a, and vertical axis, which means y-axis, right? So this will be for the discs, this will be for the washer, this will be for the discs or washer, this will be for the shells, this for the washer, this for the shell. So, let me just start off here by showing you this, right? Now, we know, so I'm going to show you how to do this. So, of course, this will have another side here. If it's rotating, it will, right? So, this is how it would look like. Then, of course, this will be connected. And then this will also be connected. Now, where does the washer come in? The washer is right here. This is the washer with a little disc within, right? So this is what a washer looks like. And this washer keeps stacking from here till the end, right? Till B. From A till B, it keeps stacking. It just becomes a washer upon a washer upon a washer. And that's why, and of course, as you can see, the thickness here is a delta, the thickness here is a dx thickness, meaning this will be going on the x-axis, meaning simply this will be rotating on the x-axis. This washer, if you flatten it out, it will pretty much just be keep rotating and rotating around the x-axis with a dx thickness, and that's simply how we get that. How we get the integral that it starts from A, right? It starts from here, it starts stacking from A till B, so till the end, right? So A till B, okay, and then what happens here? There's an inner radius, which is this one, and there's the outer radius. So, what do? Outer radius minus inner radius, so it should be r squared, of course with a pi outside right here, and then r squared minus r squared, but with respect to dx, because we have a dx thickness. So this is how our equation would look like. Of course, we cannot have a y variable here. It has to be an x variable to actually be able to solve this equation. Now, for the shell method of the x-axis, we will have the same thing. We'll have it going right here. Right? Apologize for my drawings. It's not the best, but this is my best interpretation. And we're going to have this, of course, as well. And we're going to have this as well. But what is the difference? What is the difference here? With the shell, right, we have it as a little cup here. So this, it would look like this. Right? It would look like this. It would look like a cup, really. And this cup just keeps going, right? And it keeps increasing. But our thickness here, our thickness is a dy thickness. So it's a delta y thickness. So our coordinates should go, because this will just keep going bigger and bigger and bigger till it eventually reaches this d, right? It will just, this will keep growing, this will keep growing, and it will eventually just reach the d. So our a and b values here would be c and d. So we would have our integral looking like this, from c till d, right? From c till d, and because this is the shell method, we're going to have it as, we're going to have, if you flatten it out, it will look like a circumference multiplied by the height. If you flatten this cup out, it will look like that. So we'd have the circumference multiplied by the height, so it should be 2 pi r h dy. So it's going to be 2 pi r h dy. And this is how it should look like. Circumference multiplied by the height multiplied by the dy. And of course the height here being the shell height. So yeah, this is how to find on the x-axis. Now for the y-axis, it would look a little bit different for the discs. It would look something like this, right? Just with it reflecting on the other side, and we would have, of course, the same thing right here, and of course the same thing right here, and then we would have also a washer with it that's always increasing, this being the outer, this being the inner, and our thickness here would be a delta y, meaning a dy, right? So this is what our thickness would look like, meaning we have to find this in terms of y. We need to find this in terms of the y-axis, in terms of the dy. So simply, we're going to do this same equation as this one. Again, you have the outer radius minus the inner radius, so it should be, of course, the coordinates here is c and d because it's on the y-axis. So it should, our a here should be c, our b should be d, and then we should have the same thing, of course, pi being out there, and r squared minus r squared, r capitalized minus r capitalized being the outer, and dr lowercase being the inner radius with respect to dy. So if you have anything here with related to x, forget about it. It's not going to work. Okay. So and then we've got the shell method for the y-axis, which would simply look like this as well. So yeah, let's just link them like this. It would look like this, and then we would have a cup, right? So our cup would look like it would look like this. Okay, and of course this would be at its base. So our cup will keep increasing. Our cup will keep increasing like this, right? And like this. Okay, so we keep increasing from A to B because this is not increasing this way, right? It's not increasing up, it's not increasing to the top, it's actually decreasing to the side, it's actually increasing to the sides rather than just going up. While on this part, it was actually going to, it was also going this way, meaning it was going up and going down between the C and the D. But here, it's generally just going to the A and B. So simply, it would just be the opposite, and we would have our integral as a to the B, and then we would have 2 pi r, because that's our circumference, of course, multiplied by the height, and that should be our, and multiplied by the height dx, right? Dx. And that dx should, so your height, your shell height, cannot be in terms of y, or it will not work. So this is simply the shell method and the disc washer method explained in one video. I tried to make the best of it. So here we, of course, I forgot to say, our thickness here is a delta x, meaning a dx. So that's how you also know it's a dx. So yeah, this is the best I can explain the disc and shell method. And thank you for watching, and see you in the next video.